decided it would be a good idea to make a video going over all of the review questions for the Unit 2 and 3 exam review and the Unit 1 and 4 exam review. So for this question, I need to combine these exponents. When we multiply, we add exponents. So I'm going to get 2n to the 6th, because 3 plus 3 is 6. When I have the power to a power, I distribute the power. 2 squared is 4. N squared. 2 over 4 is 1/2, so I get n to the 6 over 2 n squared. When we have exponents in the top and bottom, we subtract, so I get n to the 4th over 2. The answer is C. We went over 2, 3, and 4 in class. So for number 2, I have a power to a power, so I multiply and get 16. Combine those to get 17. Subtract to get p to the 14th over 2. For number 3, the first thing we should do is move our negative exponents. So x cubed is going to stay on top. 2 times 3 is 6. X squared times x is x cubed. And the 4 that I moved to the bottom is going to add with the 4 that's already down there to give me y to the 8th. X cubed over itself is 1. So I get answer A. Number 4, let's erase this so we can see. 2 times 2 is 4. My n and m cubed are going to stay. N to the 4th from the bottom that was negative is going to move to the top. M squared, the m to the 1st and n to the 1st that were negative on top go to the bottom and become positive. So I get m cubed over m cubed. 4 over 4 is 1. M cubed over itself is also 1. N to the 5th over n. When we subtract, we get n to the 4th. The answer is B. When we're simplifying these, it would be best to rewrite our like terms together. So if I have 6 minus 5 minus 7p plus 3p plus 7p squared plus p squared. 6 minus 5 is 1. 7p plus negative 7p plus 3p is negative 4p. 7p squared plus p squared is 8p squared. So in standard form, 8p squared minus 4p plus 1. The answer is B. When we're subtracting, we have to change the signs of all of the terms after the minus. So I get negative 8x minus 8x plus 7 minus 3 minus 2x squared minus 5x squared. Negative 8x and negative 8x gives me negative 16x. 7 minus 3 is 4. Negative 2x squared minus 5x squared gives me negative 7x squared. In standard form, negative 7x squared minus 16x plus 4. The answer is B again. When we're finding the products, I have to distribute. 7 times 2x is 14x. 7 times 5 is 35. When I have a binomial times a binomial, I need to either box or FOIL. So FOIL is first, outer, inner, last. 7m times 4m is 28m squared, so I can rule out C and D as wrong answers. 7m times 6 is positive 42m. Negative 8 times 4m is negative 32m. Negative 8 times positive 6 is negative 48. So I can rule out A as also being wrong, and the answer is B when I simplify 28m squared plus 10m minus 48. For number 9, we should definitely use a box for this one because I cannot FOIL a binomial and a trinomial. So I'm going to have 2n, and let's move this over just a little bit. So I have 6n minus 7, and I have 2n squared plus 7n plus 1. 6n times 2n squared is 12n cubed. 6n times 7n is 42n squared. 6n times 1 is 6n. 2n squared times negative 7 is negative 14n squared. Negative 7 times positive 7n is negative 49n. Negative 7 times 1 is negative 7. So I can look at this last term and help me realize that the answer has to be B, because it's the only answer that has negative 7 as my constant term on the end. So I don't even need to combine like terms. So please definitely use your strategies for process of elimination to help you identify the right answer. For this, I'm going to need to box again. So I'm going to have 5k squared, 5k, and negative 2. 7k squared plus 3k minus 1. Let's move this over. Plus 3k minus 1. Let's try to make this neat. Five k squared times 7k squared is 35k to the fourth. 5k squared times 3k is 15k cubed. 5k squared times negative 1 is negative 5k squared. 5k times 7k squared is 35k cubed. 5k times 3k is 15k squared. 5k times negative 1 is negative 5k. Not squared, just 5k. Negative 2 times 7k squared is negative 14k squared. Negative 2 times 3k is negative 6k. Negative 2 times negative 1 is positive 2. So notice all of these have positive 2, so I am going to need to combine like terms here. So notice all of our diagonals are like terms. So I have 35k to the fourth. 35 and 15 is going to give me 50k cubed, and then from there we can see that my answer has to be B, because that's the only one that has 50k cubed. So here, this is going to be a difference of squares. So notice I have a binomial A plus B times A minus B. All this plus and minus means that these are opposite. So I have negative 1 and positive 1. So I multiply this out. My middle term is going to go away. Negative 6x times negative 6x is positive 36x squared. Then I get negative 6x plus 6x minus 1. So this is going to go away, and I get B. This one is going to be a perfect square trinomial of the form a squared plus 2ab plus b squared. So if I square my first term, 16x squared, multiply these numbers times each other. So negative 4 times negative 4 is 16, and then times 2 is 32, and then last number squared is positive 16. So here, when we're factoring, we're trying to find numbers that multiply to the number on the end and add to the number in the middle. So for number 14, I'm going to have to do AC product and factoring by grouping. 5 times negative 8 is negative 40. And I'm trying to find numbers that are going to add to 39. So the most obvious answer here is going to be 40 and negative 1, because I have a negative product and a positive sum. So I'm going to have opposite signs. So then when I factor this by grouping, and let's move this out. So when I factor this by grouping, I need to split up 39 into 40 minus 1. So I get 5m squared plus 40m minus m minus 8. Group first two terms, last two terms. GCF of my first two is 5m. I'm left with m plus 8. I need this group to match the remaining group here, so I need to take out a negative 1. The GCFs become a group. My common group is the other pair. So the answer is D. I have to do the same thing here, finding numbers that are going to multiply to negative 72 and add to 71. Again, the numbers are 72 and negative 1. So I get 8n squared plus 72n minus 9. Understand that I could have put negative n first and positive 72n second. It does not change our final answer. It only changes what our GCF and our remaining factor pair are, just switches them. So here my GCF is 8n, and I'm left with n plus 9. And if I need n plus 9, I need to take out negative 1. So I get 8n minus 1 times n plus 9. So we should always look for a GCF when we're factoring here. So our GCF here is going to be 4. So I get x squared, 48 divided by 4 is 12. And 140 divided by 4 is going to be, I'm not going to try and do that in my head. I don't have a calculator nearby. So we get 3, 12, 20, 35. So then here, now that I have a equal to 1, I'm looking for numbers that are going to multiply to positive 35 and add to negative 12. So anytime I have a positive product and a negative sum, both of these numbers have to be negative. And the numbers are 5 and 7. So I get B. This problem also has a GCF. We can see that it's going to be 6, looking at our answer choices. So I get 5x squared plus 7x plus 2. So then I need to do AC product here. 5 times 2 is 10. Numbers that multiply 10 and add to 7 are 5 and 2. So I'm going to have to do some factoring by grouping here. So I get, don't forget the 6 out front, 5x squared plus 5x plus 2x plus 2. Group my terms. Don't forget to leave the 6 out there. GCF here is 5x. I'm left with x plus 1. GCF here is 1. I'm left with is 2. I'm left with x plus 1. So I get 6 times 5x plus 2 times x plus 1. If we're going to graph the function from vertex form, we need to remember y equals a times x minus h quantity squared plus k. And this is where h and k are the vertex. And because this is minus h, the vertex is the opposite of whatever is in parentheses. So my vertex for this problem is negative 1, negative 3. So it's not going to be A. This is number 19. It looks like it could be B. It's not C because that's at negative 2. And it's not D because that's at negative 1. So my answer is B. For this one, if A is negative, then it's going to open down, which means I'm going to have a maximum. So it's not going to be A or B or C because those are all opening up. It has to be D. So none of the other stuff even matters because I know that it has to be D. But looking at our equation, we should see that our vertex is going to be 2, negative 3. If we're solving by square roots, this is when we do not have a B term. So I was talking about in class how if this term is missing, I can solve by square roots because I only have one variable to solve for. So we need to isolate k squared and then take the square root. Don't forget that when we take the square root, we have a positive and a negative answer. And we need to make sure that we understand how to simplify the square root as well. 21, this one was factoring by grouping. I need to make sure that my equation is equal to 0 before I try and factor. I need to use AC product and grouping to get my factored form, set it equal to 0, and solve using zero product property. So if we're using the quadratic formula, that's going to be opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We're going to have to memorize that. And I need to still have my quadratic equal to 0. The difference between a quadratic formula and factoring is I don't care if a is negative. It does not matter. So I can write this as negative 2n squared minus 9n plus 95. Identify a, b, and c. Let's write that out. A equals negative 2, b equals negative 9, c equals 95. So I'm going to get opposite of b, 9, plus or minus the square root of 9 squared minus 4 times negative 2 times 95, all over 2 times negative 2, which is negative 4. And if we put that in our calculator, because this is a decimal, I can put the whole thing in my calculator, and we should get C. So if we work this out piece by piece, 9 squared is 81. Negative 4 times negative 2 times 95 is 760. Plus 81 is 841. Nine plus or minus the square root of 841 over negative 4. The square root of 841 is 29. So if I have 29 plus 9 divided by negative 4, I get negative 9.5. If I do 9 minus 29 divided by negative 4, I get 5. So make sure we understand that this is two different answers. So x is going to equal 9 plus 29 over negative 4, which is how we get negative 9.5. And x equals 9 minus 29 divided by negative 4, which is going to give us positive 5. So all of this right here is for number 22. Oops. So we had 23 over here. So if I have a simplified square root, I can only do what's underneath the square root in the calculator. And then from there, I need to simplify. 181 does not have any perfect square factors. For number 24, we follow the same process. So I'll do 24 over here. So 24 is 6 plus 6k equals 7k squared. So if I get all my terms on one side, if I subtract 7k squared, I get negative 7k squared plus 6k plus 6. A is negative 7, B is 6, C is 6. Okay, so if we're going to set up the quadratic formula for this problem, we have opposite of b is negative 6 plus or minus the square root of b squared is 36 minus 4 times a times c all over 2a, which is negative 14. So then I get negative 6 plus or minus. So this one is going to be a simplified square root. So I do not want to put this whole thing in the calculator. So I want to do 36 minus 4 times negative 7 times 6 to get 204 over negative 14. So if we're thinking about 204, that's divisible by 4. So if I have, this is going to equal negative 6 and negative 14 can simplify to positive 3 over 7. And we said that this was the square root of 4 times the square root of 51. And actually, let's not simplify that yet, because I need to simplify this too. So I'm going to have negative 6 plus or minus 2 root 51 divided by negative 14, which is going to simplify to 3 plus or minus the square root of 51 over 7, which is C. These last few problems, we're looking at the discriminant, and we have some radical equations. So our discriminant is the part of the quadratic formula that's under the square root. So if I'm trying to find b squared minus 4ac, I need to make sure that this is set equal to 0 first. So let's put 25 down here. So if I have negative 7v squared equals 10 minus 10v, and I want all of my terms on one side, I'm going to have negative 7v, I guess I could just move that one, 7v squared plus, let's get it in standard form, minus 10v plus 10. So a is 7, b is negative 10, c is positive 10. So b squared is going to be 100 minus 4ac, 4 times 7 times 10. 4 times 7 times 10 is 280. Just kidding. Wait, no. Hold on. 4 times 7 times 10. Yes, 280. So 100 minus 280 is going to be negative 180. So because this is negative, I'm going to have two imaginary solutions. I cannot have a negative under my square root to give me real solutions. It's going to be an imaginary solution because the square root of negative 1 is I. So when we have a negative under our square root, we're going to have two imaginary solutions. For 26, I did that one right here. So this is 26. I have b squared minus 4ac. A is 8, b is negative 4, c is 0. So I get negative 4 squared is going to be 16. If I take the square root of 16, I get plus or minus 4. So it's not going to be irrational. They're going to be two rational solutions. For 27 through 30, I'm using square roots to solve these. So to get rid of a square root, I'll need to square it, but first I have to isolate the square root. So I'm going to subtract 6 and get 10 equals the square root of a over 2. If I square both sides, I get 100 equals a over 2. Multiply both sides by 2, I get a equals 200. Answer is B. For number 28, if I have two radicals on opposite sides of the equation and there aren't any other terms, I can just square everything. And then I get 4m equals 3m plus 1 minus 3m. So m equals 1. Answer is D. Then we have k equals the square root of 6k. So this square root's already by itself, so I can square both sides. And let's do this in different colors so we can see. So I square everything, and I get k squared equals 6k. So now this is quadratic. So I'm going to need to solve by factoring. So I get k squared minus 6k equals 0. My GCF is k, and I get k times k minus 6 equal to 0. Now I can use zero product property to get k equals 0 and k minus 6 equals 0, which means k equals positive 6. So the answer is B. And last but not least, I have a radical equals a binomial. So again, this radical is already by itself, so I can square both sides. And I get 7, and I'm going to need more space for this one. Let's come down here. So if we grab this, come over here. So when I square both sides, I get 7x minus 45 equals x minus 5 quantity squared. So that's very important that we realize that I have to square this as a binomial, which is going to then become a perfect square trinomial that will need to factor back down once I set this equal to 0. So we find our perfect square trinomials, a squared plus 2ab plus b squared. And if you can't remember this, you can always just box or FOIL to find the answer. We get x squared minus 10x plus 25. And now I need to set this equal to 0 so I can factor it. So I'm going to subtract 7x and add 45 to get x squared minus 17x. 25 and 45 gives me 70. And now that this is equal to 0, I can factor it. So I'm trying to find numbers that multiply to positive 70 and add to negative 17. This means that I'm going to have two negative numbers. That's the only way for me to get a positive product and a negative sum. The numbers are 10 and 7. So this factors to x minus 10 times x minus 7 equal to 0. Using zero product property, x minus 10 equals 0, x minus 7 equals 0. So x is going to equal positive 10 and positive 7. Our answer is A. So that takes us to the end of our answers for our Unit 2 and 3 review. I will do a separate video for Units 1 and 4. So make sure that we watch this video and review these answers, and there's the list of all of the answers.